Hello and welcome. Sorry for my eyes have infection. So let's go to this example 5 that I'm going to show in this video. So the problem statement is like this: you have a conveyor which has total 0 to 15 stations. Stations are numbered from 0 to 15, with station 0 being the first, the point where parts enter the conveyor. Parts are to advance along the conveyor at the rate of one station every 4 seconds. A part may or may not be at a given station at any point in time. That means part will move from one station to another. By that time, there may not be any other part in front of the station. An input sensor 1 is used to detect a part entering the conveyor. So we are assuming that sensor is installed in station number 0, the first station. At station 5, which is actually sixth station, because number is from 0 to 5, so this is sixth station. Parts are checked for defects and input sensor 2 is energized if part is defective. At station number 10, any defective parts are to be removed from the conveyor by energizing output. A pusher will be pushing the defective parts and remove from the conveyor. So now we have to write a very good ladder for that. So this is a picture, graphical representation of that. So 0 number station is the entry point. So from here to the next station it takes 4 seconds, and so on and so forth in every it's a single conveyor. Now number 5, the fifth station has a sensor 2 that detects defective parts. Now how many gap in between 0 to 5? 1, 2, 3, 4, 5. So it should take 4 into 5, 20 seconds to reach fifth number station. So when fifth number station has sensor 2 detects the faulty sensor, it registers the station number and that defect part to be removed from the station number 10. So now when it detects default faulty part here, from here we count 0 second again, 0 and then 4, 8, 12, 16 and 20. So in another 20 seconds we can remove that part. So we're going to use the shift register. So we have to use two registers for that. One is for conveyor station number, another is for faulty parts registered in any station number. So let's go how we did. We have to follow the procedure how we create the project, and then we need some hardware for that, input module and output module. Basically we have to list down the input and output. We are going to use one function for that, ladder programming. Let's go to the program and see what. Okay, so this is the program. Okay, so this is the program. Now before we dive into the ladder logic program, let me give you some brief what I have done before starting the programming. First I have prepared a tag for that example 5. So this is our tags: sensor 1, sensor 2, pusher, and I have listed out 2 more tags but not used. I'll tell you why. Actually, I use them here in data block inside. So I have 2 registers, one for sensor detected parts, another for parts defects position, and one timer is used that is inside timer data block, 4-second timer. And then I have defined a watch table for testing. Example 5. So this is a watch table. Now let's go to the example ladder program. As usual, I do always read the input status and copy them into wall underscore di. Now, wall underscore di is this one. So it has the bits that I need for sensor 1 and sensor 2, and then the last network I use the do all do dot user and send them to digital output. This is my standard practice framework, as you can say. Now the one freewheel timer is running in the network 2, that is timer for 4-second time, and is going to run like when it is not running, start the timer, when it is done, restart. So that way it will continue. We'll be doing that, and we will be using the timer done bit for remaining program. Now this timer done bit, what I have defined here, this timer done bit is done especially for this version of TI portal. Usually we, without using this, we can use timer dot, this dot qubit directly like this, and this bit we can use for many places, but this version of TI portal has some bug, so that's why we use separate memory bit. Okay, then when timer is done, a positive pulse is used or done bit, and then shift SHL, shift leftward, that instruction is used, which actually uh, shift bit by bit, one bit at a time. So one bit shift left side every 4 seconds, because the conveyor, if you understand the process, conveyor is moving every 4 seconds from one station to other. So if this is my one station and another station is this one, so this will move like this, 4 seconds. The next 4 seconds will move like this. So this instruction will execute in every 4 seconds. Now the same timer done status is checked here, and another register also shift one bit at a time parallelly, that is parts defect position. So I will come later why we use this one, because in the next run we have used this. Sensor 1 actually sets the first bit position of this register, detected position, and the sensor 2, so this bit 5 position, when the bit 5 position had some parts, it was detected, and because the position is moving every 4 seconds, so when that position got moved to position number 5, and that has value 1, true value, and then at the same time sensor 2 is detected, that means the parts is faulty. That means the position 5 parts is faulty, so we actually set defect position 5, the another register. In that register we set bit number 5 just to register that this position has a what I can say, this position has a parts which is detected as a faulty parts. So now we have to check that position again in 10th number station. As if you see this picture, so in the 5th station we registered that the parts is faulty, so we are going to remove that from the station number 10. So after 20 seconds it will be removed from the station number 5. So this is done in the next network, remove defected part, and we are checking the same register because this register is shifting a bit, one bit at a time in every 4 seconds. So when that bit reaches to bit number 10, that value of x5 reaches to bit number 10, then we enable the pusher that pushes the defected part out of the conveyor. So that's the program, and we are then moving this value to the module which is actually connected to the field. Now if you see the simulation, this is what it looks like. Okay, so we can simulate this value. Let's simulate sensor 1. Sorry, it's supposed to be this one. Okay, the watch table is this one. If we enable the sensor 1, which is entering parts into the conveyor, it will register this bit. So 1 bit is registered, 2 bit is registered, and now when one of the position is to 5th position, if we enable this, when it reaches 5th position, okay, so you see this defect parts 5th and 6th position is registered as faulty because it's always on. Now I remove that, so now we have two position as a faulty registered as a faulty uh, parts. So two station has you can say faulty parts. So now it is pusher is 1 because the 10th position reached that bit. So interesting, it was like that.